Hello friends, uh, let us now learn some important points about the cones and cylinders. The second type of X-ray beam restrictor comes in two basic shapes, that is conical and cylindrical shapes. So this is a cone and this is the cone shaped X-ray beam restrictor. You can see the focal spot and this is the X-rays which occur. This is by entire portion of the beam, and whereas penumbra is only by a small portion, that is edges of the beam will result in penumbra. Then we can see the same thing for cylinders. So this is the cylinders with focal spot and two areas, that is again umbra and penumbra. The restriction occurs at the rear end of the cylinder. So if you see first cones, the flare shape of the cones would seem to be the ideal geometrical configuration for an X-ray beam restrictor, but the flare of the cone is usually greater than the flare of the X-ray beam, in which case the base plate that attaches to the device to the tube housing is the only part that restricts the X-ray beam. When used in this way, it is little more than more than an aperture diaphragm. Then, if we use the cylinders, the beam restriction in the cylinders takes place at the far end of the barrel. So, there is lesser penumbra. These cylinders are maybe equipped with extensions to increase their length to give even better beam restriction. Then, so beam restriction in cylinders is more than cones, more than aperture diaphragms. So the penumbra for aperture diaphragms is more than the cones, more than the cylinders. The major disadvantage of aperture diaphragm, cones and cylinders is severe limitation they place on the number of available field sizes. Even a large assortment cannot approach the infinite variety of field sizes which is needed in diagnostic radiology, and changing the field size is very difficult for these aperture diaphragms, cones or cylinders. Then the next type is collimators, which we will learn in next class. Thank you.